This is going to be a short video that talks about how to change the coefficients and the energy term in a thermochemical equation. We're going to walk through two examples. The first example is given here. So we have the reaction for the combustion of ethane. So 2 moles of ethane react with 7 moles of oxygen to produce 4 moles of carbon dioxide and 6 moles of water, plus 2,620 kilojoules of energy. So we're going to rewrite this thermochemical equation for the combustion of 4 moles of ethane. Now you might be able to see this and just automatically do the math in your head. We're going to walk through a process that, if you're a little bit lost, will give you the right answer. So we're going to write this as, we're going to call this reaction A. And this reaction with 4 moles of ethane, we're going to call reaction B. So to find our enthalpy change, we're going to say that for reaction A, we have 2,620 kilojoules in reaction A. And then we're going to multiply by the mole ratio. So in reaction A, there are 2 moles of ethane. The reason that we're going to do this math is that allows us to cancel out these reaction A's. So now we know the kilojoules per mole, or the molar enthalpy for ethane. We know that in reaction B, there's going to be 4 moles of ethane. And so we're going to just write 4 moles per reaction B. And so now we've taken this molar enthalpy of ethane, and now we have kilojoules per reaction B. So that's going to give us an enthalpy of negative 5,240 kilojoules. So we're just going to rewrite this equation now and plug that in. So ethane plus, we have 4 moles of ethane. Since we doubled the moles of ethane, we're going to double the moles of oxygen, so 14 moles of oxygen. We'll also double the moles of carbon dioxide, the moles of water, and our energy terms. So everything's been multiplied by a factor of 2. Our second example, so we have the reaction, the decomposition of iron 3 oxide. So it forms iron 2 oxide and oxygen. And we have an endothermic reaction in which 570 kilojoules of energy is absorbed when this reaction takes place. So we're going to rewrite this for the formation of 1 mole of iron 2 oxide. So we have 4 currently, we're going to rewrite for 1. So again, we're going to call this reaction A, and the reaction involving 1 mole of iron oxide is going to be reaction B. So our molar enthalpy for reaction B is going to be 570 kilojoules in reaction A. We're going to multiply that by the ratio, or the coefficient, for iron 2 oxide, which is 4 in reaction A. So there's 4 iron 2 oxides in A. And then in B, there's going to be 1 iron 2 oxide. So again, if we look at our units here, reaction A's will cancel, and moles of iron 3 oxide will cancel. So we have kilojoules for reaction B. And that's going to be 142.5 kilojoules. So we've divided the number of moles of iron 2 oxide by 4. So our new equation, we're going to divide everything by 4. So 2 divided by 4 is 1/2. So 1/2 iron 3 oxide. And this is going to be a thermochemical equation, so we're going to include our energy term, plus 142.5 kilojoules is going to form 1 mole of iron 2 oxide plus 3/4 moles of oxygen gas.